Hi everyone. Today we're going to study logical equivalence. Let us define logical equivalence. The compound propositions P and Q are called logically equivalent if the biconditional proposition P, if and only if Q, is a tautology. We use the symbol like this, and this is read as P is equivalence to Q, or P is logically equivalent to Q. Let us see this example 1. Show that P implies Q is logically equivalent to not P or Q. For our solution, let's begin with writing the tables for the values of P and Q respectively. And then, let us first evaluate the right side of this equivalence. Let's begin with the negation of P. So not P is here with the corresponding values for T becomes F and F becomes T respectively. Now, let's have not P or Q. Remember that for the OR operation, this is only false when both of their propositions are false. So the values are F or T is T, F or F is F, T or T is T, T or F is T. Next, the P implies Q. So the values are T and T is T, T and F is F, F and T is T, F and F is T. Remember that for the implication, this is only false when P is T and Q is false. Now, let us consider this column, not P or Q, and the column P implies Q. We can see that they have the same truth values everywhere. So we write, since P implies Q is true whenever not P or Q is true, and P implies Q is false whenever not P or Q is false. Therefore, P implies Q is logically equivalent to not P or Q. This is our final answer. Example 2. Verify that the negation of the compound proposition P or Q is logically equivalent to not P and not Q. Let's begin with writing our table for P and Q with the corresponding truth values. Then, let us evaluate P or Q. And here are the corresponding truth values. T or T is T, T or F is T, F or T is T, F is F. Next, we will negate this column. So T here becomes F and F becomes T respectively. And then, let's have the negation of P and negation of Q. So all the values of P and Q are negated on these two columns. And then, let's have not P and not Q. So we have F and F is F, F and T is F, T and F is F, T and T is T. From here, let us compare these two columns. We can see that they have the same truth values everywhere. So we say that since the negation of the compound proposition P or Q is true whenever not P and not Q is true. And the negation of the compound proposition P or Q is false whenever not P and not Q is false. Therefore, the negation of the compound proposition P or Q is logically equivalent to not P and not Q. This logical equivalence here is part A of De Morgan's law for propositions, while the part B is here. The negation of the compound proposition P and Q is logically equivalent to not P or not Q. We're going to leave this part B of De Morgan's law for practice for students. Let's have example 3. Show that P or the compound proposition Q and R is equivalent to the compound proposition P or Q and the compound proposition P or R. We can see here that we have three propositions P, Q, R. So let us start with the truth values of P, Q, R respectively. And then let us evaluate Q and R. And the values are here. Next, let us evaluate P or this Q and R. This is our P and this is now the Q and R. Let us connect them with the operation OR. The values now are here. And then let us now evaluate P or Q. And the values are here. Next, let us have the P or R. And the values are coming now in here. And then let us have this P or R and the compound proposition P or R. So we will connect these two columns with the operation AND. And the values now are here. Let us compare this column with this column. We can see that the truth values are the same correspondingly. So we say that since P or the compound proposition Q and R is true whenever P or Q and the compound proposition P or R is true, and P or the compound proposition Q and R is false whenever P or Q and the compound proposition P or R is false. Therefore, P or the compound proposition Q and R is logically equivalent to the compound proposition P or Q and P or R. Take note that what we prove here is the part A of distributive laws. And the part B of distributive laws is here, P and the compound proposition Q or R is logically equivalent to compound proposition P and Q or the compound proposition P and R. We're going to leave this part B for students to prove. I hope you learned something from this video. See you again next time.